Hi everyone, I'm going to be creating an instructional video to enhance my Lesson 3, Activity 10 in my thematic unit, Forces in Motion. So my instructional video is going to act as a simulation for a Play-Doh experiment. I have found when teaching kindergarten that some students have trouble seeing where I am in the classroom when modeling or demonstrating something. So I opted for a document camera to show my modeling or directions, so that way students have a more equitable view no matter where they are in the classroom. For my video, I am going to make a simulation of slides 7 and 8 in my slideshow Forces in Motion Lesson 3. I'm going to be reading the questions that are highlighted in yellow, as well as offering time for students to pause the video and do my instruction. Not only does this instructional video offer an optimal view for all students, but it also offers multiple means of representation. So when I am helping another student, I can play this video for a more independent group of learners, and they can follow it that way. This is also helpful if you need to pause, rewind, or go forward in the video. When I start the simulation, I just want to give a disclaimer. I'm going to be pretending as if I'm talking to a group of children. So I don't want you guys to think that I'm being condescending in any way with how I'm asking my questions or phrasing them. But I just want to make it clear that this is meant for a kindergarten audience. So I'm going to be speaking as though I'm speaking to a group of kindergartners. And the simulation starts now. Hi, scientists. Today we are going to be working with different kinds of force. We could be working with strong forces or weak forces. So we are going to use our Play-Doh to start. So I'm going to take out just a little bit of my Play-Doh, and I'm going to take my two hands like I'm clapping or making a round of applause, and I'm going to roll my ball together. Watch my hands if you're not too sure how to roll a sphere. This is what your ball should look like. Now that we have our bowl of Play-Doh, we're going to take a fist, and we are going to apply a light force or a weak force to this ball of Play-Doh. We're going to do this by gently pressing our fist into the Play-Doh ball. Here's my fist, and I'm going to gently apply pressure to the ball of Play-Doh. What happens, scientist? What do you see? What do you notice? Take some think time. If you're still not sure, lift up your ball of Play-Doh and look at it. We are observing like scientists. Move your ball around to get a view of everything. What happened? What did you notice? All right, now we're going to move on to the next step of our experiment. We're going to take our Play-Doh and roll it again into a ball. Once your ball of Play-Doh looks like this, give me a thumbs up. All right, so now we're going to take our fist again, but this time we're going to apply a stronger force. That means that our fist is going to go a little bit harder and a little bit deeper into the ball of Play-Doh. All right, I have my fist. Let's apply a stronger force. What happened? What did you notice? If you're not sure, you can observe your Play-Doh like this. What happened? What did you notice? How does the Play-Doh with the lighter fist or the weaker force compare to the second harder fist, the strong force? How were the forces alike or the same? And how are the forces different or not the same? What is another name for the push you applied to the Play-Doh? It starts with a sound. How would you describe the different forces you applied to the clay? What does this tell you about the strength of the forces? Which is a weak force and which is a strong force? Great job, scientists. Now we're moving on to phase 2 of our Play-Doh experiment. Instead of using our fist as the force, we're going to use our finger instead. So start to roll your ball into a sphere again, and once it's ready, give me a thumbs up. So now we're going to focus on how our direction of our force impacts the Play-Doh. So we're going to take our finger and we're going to poke the side of the Play-Doh. This is the right side. This is my right hand. I'm holding the Play-Doh with my left hand. So I'm going to take my finger and gently touch the Play-Doh. I'm going to try to push it just a little bit. Here's my light force. Now I want to roll it up again. What kind of force do you think we're going to use this time? A strong force, that's right. So I'm going to take my finger, and again, I'm going to use my right hand, my right pointer finger, and I'm going to use a stronger force when I make contact with the Play-Doh ball. Ready? Here we go. Now we're going to make our force come from up to down. So I have my ball again. Make your ball if you haven't done so already. I'm going to take my finger and gently press down. My indentation's now on the top. I'm going to roll it up again. And then I'm going to use a stronger force with my finger to push down. What happened? What do you notice? How did pushing on the clay from the side affect the clay? How did pushing the clay from different directions affect the clay? What is a science name for the push you applied? It starts with a f sound. How would you describe or tell someone the different forces you applied to the clay? Were they strong forces or weak forces? Okay, so the simulation's over. Thank you so much for watching my instructional video to enhance my Lesson 3 Activity 10. I look forward to watching your guys' videos as well.